Thank you. Okay, hey everyone. I'm Omar. I'm the organizer of the .C meetups, and I'm very happy to have you here today. And my presentation is about implementing a notification system that we designed and implemented in one of my previous jobs. And my goal is to share with you our approach to it, and also hear if you implemented a similar system, what you did, and how this design can be improved. So let's start. Oh, I pressed something. Dean.
You pressed it?
Let's start with the functional requirements. So number one, we want the system to be able to represent the brand. So emails, for example, should be able to support rich HTML that preserve the company's colors and UI components and whatnot. We also want it to be multi-channel. So the system itself should be able to support email, push notifications, SMS, and then in-app notifications, the kind of red dot that you see on your profile. And we also want it to be customizable, so the users are able to choose certain notifications to receive, and also they should be able to set times during the day where they want to mute their push notifications. Well, generally users can do that through their operating systems, but we want the app to have that feature. And we want it to be multi-trigger. So API, backend servers, as well as serverless, as well as business people should be able to, at will, send notifications to specified users, as well as by certain conditions. And finally, we want it to be able to prioritize certain notifications because some of them are critical, such as sending a one-time password to email or SMS. And thank you. Yes, fixed pattern habit. So some of the non-functional requirements for the system, it should be highly available, as we mentioned, because we have very critical notifications. For example, if the user doesn't get the OTP, they will not be able to sign up. And we might lose users or have them talk about us on social media, and then we have to do sentiment analysis to discover that.
Yeah.
And then we need it to be low latency, because for example, an OTP has an expiration time, for example, 5 minutes. It doesn't make sense to send it to the user at the end of the notification stack. And we also want to preserve our reputation for email. So I don't know if you know this, but email in general, or your domain, would probably suffer if you send emails to receivers that don't want to receive you, and there are multiple ways that they can signal to you that we don't want your email, and you should be able to respond to that. Next. So a high-level view of the system is that, and here this is a very, very sort of a simplified version of it. I wanted to make it as minimal as possible. So we have our backend servers, and we have our serverless functions, and this is kind of a wrong representation, because by serverless functions we mean triggers that happen as a response to something that is not related to the user, or something that is more like a cron job. So the backend server, for example, user A likes user B, so we need to send a notification to user B. And then the Lambda, or the cron example, would be like a daily digest or weekly digest or something of the sort. So all of those notifications will be, so the backend server and the serverless functions don't really know the content of the notification. They just know what notification and what parameters need to be sent. And we send it to the queue will prioritize it, and then we'll fire up a Lambda function to discover what kind of notification it is, and what are the necessary data that we need to get from either DynamoDB or Firebase to access a user. In this example, we only send the user ID, so it's kind of not a very useful information. We get the email from Firebase, and then we fire up an email if the notification is an email. Otherwise, we tell Firebase. Firebase has a very good feature called Firebase messaging, which allows you to send push notifications. So we just tell it which user to send the notification to, and in order to have this information, we have to consult with DynamoDB, because when the user signs up to our app, we get their device token, which is only relevant to Firebase, and we store it in DynamoDB in case we want to send them a notification. And then in app purchases, this is also a Firebase feature, uses Firestore, which register the device as a listener to only this particular user records, and we send sort of temporary records to the Firebase Firestore. We store that we send the data there. The device discovers it, and then we delete it immediately. And then the device will know that there is updated data in the server that they need to get. So in this way, we'll be able to, through this function, decide which to send, and we'll be able to queue this in a way that prevents sort of overflowing the system with messages and messages not being delivered. Okay, that's it. So just these are the takeaways if you're interested. The presentation is there. And then the last slide. These are the services that we've used. After I finished this presentation, I discovered that there's one, which is AWS CloudWatch that we're using that is not here. Thank you very much.
Yeah.
Cool. So, 10 minutes of Q&A.
Got a question.
Sure.
How do you make sure the reputation is good with your emails? How do you make sure you don't end up in like the spam filter? Just curious.
Well, so when there are multiple ways that the user can signify to you that they don't want to receive the email, and by the user here, I mean either the user themselves or their email provider. Wow. So, for example, an iCloud email might be obsolete if the user leaves the service or something like that, or they might use a temporary email. So in that case, the mail provider will send you a response to your email saying this account doesn't exist. So it's a permanent bounce, and you should never send an email to that address again. If you keep sending email, the email server provider will know that you're kind of not.
So they send you a trapped email. What? Sorry?
So there is a feedback loop to email.
Yeah.
And when you send an email, usually you receive a feedback response of 3 options: either complaint, bounce, or delivery.
Oh, okay. Right.
So you can register this data, and we register this data in DynamoDB. Yeah. Whenever we want to send an email, we consult DynamoDB to see if this email address is okay to send or not. Yeah. And yeah, that's how we prevent. So actually, we had a problem with reputation. It wasn't alarming, but it was going up and up. So we had to implement this system, and it cut down the bounce rate very significantly.
Okay. Cool.
Thank you.
So what is the blue icon on the... sorry, can you go back? What is that? Oh, is that the device?
This one?
Oh,
That's the device. Sorry.
Oh, okay.
It's draw.io, so I couldn't find anything. So. Sure.
What language do you use for implementing your serverless functions?
That's a very good question. Could you go back to the takeaways? So the strongly type. This is extremely important because you have so many. Let me answer the question first. TypeScript. You have so many items, and it's really hard to kind of exhaustively test all of them, either by code or by hand. So having a strong type here will prevent you from like sending, because you can send a notification from the server, and the Lambda was like, I don't know this notification, I don't have any email context for it, so I'm just going to ignore it. So yeah, TypeScript served us very well in this case. Thank you. Okay.
How do you test your system? Because it says stress test, but like, how did you stress test it? Did you deliver it to like lots of devices, or what did you do?
Actually, so I sent a lot of, so I did things that trigger a lot of notifications, such as trying to log in like 1,000 users or something like this. And the goal was to discover limitations by the providers. Because if you're using a mail provider or email service provider like Amazon Simple Email Service says, you are generally bound to a send rate of 14 email per second. And you can apply to go over that, but you will not discover that until you hit it. And of course, users will not receive email, so we have to do benchmarking. So fire requests from our clients to stress the system.
Did you make like a lot of fake email addresses to send yourself emails, or did you send all to the same address?
So the good thing about Amazon SES is that it has options for sandbox emails, where you can send, if you send to this email, you will receive a success. If you send, you receive bounce, so you can test that. Way. And then another way of testing is just testing that the actual emails are going to have the HTML that you expected, and these are just unit tests, so easy to do.
Maybe a silly question, but so in terms of the Lambda functions, how do you decide, maybe I understood it wrong, but how do you decide whether to send an email notification or a push notification? Is this like a complex criteria, or this is something decided beforehand, or depending on the user?
So this is decided by business. First, we want, if this happens, we want to do this and that. And then we take this data, it's a Google Sheet, so it's a nightmare. So we take this data as CSV, and then we transport it to code, and then we every event that happens has should send an email, kind of a flag, like should send an email, should send a push notification, should notify the app, or generally we just notify the app about everything that happens, and then the app will decide whether to do something about it or not. So the Lambda will have this information as hard-coded in its code base, essentially.
Okay.
Yeah.
Is Amazon SES pretty easy? Is it SES? Is that what you're using? Amazon SES?
Yes.
Is that pretty easy to use, or
For what use case?
to handle sending your emails?
Very easy, extremely easy. It might not be. Sorry, go ahead.
Oh, sorry. Do you use your own domain or something with that?
Yes.
Or? Yeah. Okay.
So SS allows you to verify your domain, your email address. I think up to 10,000 email addresses. So very easy. Receiving, on the other hand, is not very straightforward because you don't know what to do with the email. You can fire a function or store it in S3. So it requires a little bit more work. Okay, any questions? If not, may I ask question then?
Yeah, of
Anyone
course. Yeah.
ever implemented a notification system or something similar to this, or is considering implementing one?
Definitely considering.
Yeah.
Okay,
I have one.
Consider.
you have one.
Oh.
Okay. Is it okay? I think it's okay for me, right, to ask him, right?
Yeah, of course. Yeah.
So we have 4 minutes. So what's your approach to it?
So there, like I don't want to criticize anything, but one thing we noticed, actually, my first iteration was almost exactly the same as this. But what quickly became apparent is that serverless functions are extremely expensive. And so if you end up sending like maybe 200 or 300, well, it depends on the scale of the system, but like we do like maybe 1 million notifications a day. And when that happens, the serverless is much more expensive than if you were to pick like like an EC2 or some kind of other hosted solution. Like I don't remember what the Amazon like Docker container host is, but
Yes.
yeah, serverless is extremely expensive, and it will shock you when you get the bill.
It is, and there is also hard limits to like 1,000 executions per second. I think concurrent executions. So if you have this load, you might actually not be able to use Lambda.
Yeah,
at all.
you run out of quota,
Yeah.
and it will be very expensive.
So the question is,
Damn.
how do you handle the queuing then? Because it's okay to have EC2 here instead of Lambda to handle. But so do you use a queue to prioritize the messages?
Yeah, we so the also like queue depends on which queue you pick, right? But I don't believe queue has like a scheduling time, right? So how do you handle like the case where like let's say the user reserved the messages for 6 p.m. or something, right? Like how do you, because queue will just do like an at least once delivery as soon as possible, right?
Yeah.
So how do you like schedule notifications in the future if you do this?
Database.
So you
Database
write in the
and
database,
cron, yeah.
and then cron, and then
Yeah.
you do. Oh, okay.
Yeah. So I mean, we don't have that use case, but that's generally the approach that we would take in this case. So what happens? So if you have, let's say, 1,000 events in your backend that you need to notify 1,000 users about, you use a queue, and then the queue will send the messages to the EC2.
Oh, okay.
That's
No.
what we do.
So we use a different solution. So there's this thing called like a Google Cloud Tasks,
Yeah.
which is like a queue, but it has a benefit of being able to wake up a task at a certain time. So we simply stick all of the triggers
Yeah.
into the queue, and then the queue wakes up later. So we don't have to start
So
any
batch them
database.
together.
Yeah, yeah.
Not that's very
Yeah,
smart.
or
yeah.
we schedule it at the scheduled time, right?
Yeah,
So
yeah.
like we'd say like we have to send it at 6 p.m. Then the queue will wake up the task at 6 p.m. and then invoke the container.
And then if you have some more critical ones, they will go to
Yeah.
directly through
Yeah.
a different channel.
Yeah.
That's
Or
very
you
smart,
can
yeah.
schedule them in the past, right? And then it will invoke immediately.
I see.
Yeah.
Oh, thank you. That's so smart.
What queue do you use?
So it's called Google Cloud Tasks.
Yeah, but how do you queue that?
Okay. So we have multiple ways. One is we use a storage trigger. So like they upload a huge CSV, and then we use there's a storage trigger, and then you parse the CSV as soon as it shows up in the storage bucket, and then it puts that into like some form of database. We use Spanner, but you could use any database. It doesn't really matter, right? And then the task will wake up the handler at the time, and the handler will fetch the targets out of the database and then send.
Interesting solutions. So one of the problems is that you might occasionally have messages in the queue that fail to execute because of your data, or Firebase doesn't find the email that you said or something, or you just have a bug in your code. So in that case, we have a dead letter queue that takes all those messages that failed so that they don't block the queue, and then we handle them later. We actually never had to do that, but we have it in place. in your solution, did you have to resort to something like this?
So it's complicated because some notifications you want to resurrect, and some of them you want to just drop it, like because they're time sensitive, right? So you have to set like a TTL and then like make like a judgment call as to whether or not to retry. So it's pretty like we end up usually like having like a person go through like the dead letter queue, but yeah, it's
Interesting.
complicated.
Thanks. We don't have enough time, but I'd like to hear. We have 14 seconds, so thank you very much. Enjoy talking to you.
Thanks, everyone.